Welcome to Unit 5 Reasoning. This is Day 2, Algebraic Proofs. Now, all of these properties you already should know from your previous math classes. This is actually kind of spelling out what they are, such as if A equals B, then A plus C equals B plus C for real numbers A, B, and C. That's called the addition property of equality. You can see the rest of these. These create our algebraic properties, and that's what we're going to use largely today for the kinds of proofs that we're doing. We're doing algebraic proofs, so it's going to be using these properties of equality. As a matter of fact, I'd probably suggest kind of like having these properties somewhere handy. Maybe you kind of like do a split screen while you listen to my notes so you can see where everything's coming from. So here's example 1. It says justify each step when solving an equation, and it goes ahead and jumps right and gives you an equation right there. I'm going to go ahead and rewrite that as if I were doing my notes, and I would say as the justification for this step is that it is given. This was a given equation. And almost all proofs, really you're going to start off with your given information. Next thing I'm going to do is go ahead and distribute, as your probably first instinct is. And if you look at the properties on there, that this would be done by distributive property, is what I just used. The distributive property of equality. Now, it's okay if you kind of abbreviate through here. That's fine by me. Next thing is y'all would say, all right, let's combine like terms. So negative 6a minus 4a is negative 10a, and 10 minus 28 is minus 18, and that's equal to 92. Now, a lot of people would write for that, combine like terms. I'm okay with that. You would see a lot of teachers use that kind of terminology. Just to give you a heads up, what your textbook calls this is substitution. You're replacing negative 6a minus 4a with negative 10a. You're replacing 10 minus 28 with negative 18. So the book will call this step substitution property of equality. Moving right along, we would get to negative 10a would equal 110. Now, how did I get there? We used addition property. We plus 18 plus 18. I didn't show that, but that's how we get there. So that's the addition property of equality. And now we're ready finally for our last step, that A would equal negative 11, and that's by the division property of equality. You can tell how this lines up, that every time I'm writing a property out beside it, it's how I got to that step. This is how I got there. And so I will have a reason, a justification for each and every step, including my first one, which was given. Okay, on example 2, this is called a literal equation where we have multiple variables. This is basically a formula, and that's exactly what it is, that distance equals 20 times the amount of time plus 5. All right, and now we're going to justify that time would equal distance minus 5 over 20. So it says given this one, so that's actually where we're going to start, that we are given that d equals 20t plus 5. And where it says make a 2-column proof, what that means is it's going to look like a T-bar, basically. You're going to have your statements over here on the left. And you're going to have your justifications over here on the right. I've also seen it labeled steps and reasons. That's fine. Just the different ways that you can actually write it. Let me shrink this down just a little bit so we can fit everything that we need to on here. So there's statement 1, and the justification for that again is given. Almost all of these will start that way. Now they're wanting us to get it to t equals d minus 5 over 20. To do that, I'm going to solve this for t. First thing, I'm going to actually subtract the 5. So it will be d minus 5 equals 20t. I just used the subtraction property of equality. Please don't put sub property because I wouldn't know the difference between substitution and subtraction. So subtraction property. Step number 3, I would divide by the 20. So d minus 5 over 20 equals t. That is by division property of equality. And now some people would say, oh, well, you're there. Well, actually, technically, the t needs to be on the left for it to perfectly match what we were supposed to get to. In order to do that, I can flip my equation around that t would equal d minus 5 over 20. That property is called the symmetric property of equality. And that was on that list that we started the class with. And that wraps us up. We have made a 2-column proof to show that those two equations are the same. All right, just so you know, there is a kind of proof. There's different kinds of proofs. We just did a 2-column proof. That's known as a formal proof. There's also a paragraph proof. It's known as an informal proof. There's also what's called a flow proof, and I'll just have to show you one of those at some point. By and large, what I'm expecting you to do in this class is a 2-column proof, and that's kind of like mainly what you're going to see in math is 2-column proofs. These are conditional statements. If-then statements, we're making conclusions based off of what we already know, so these are deductive arguments. This fits right in with day 1. All right, here we're going to see a little bit of a proof dealing with angle measures and angle congruency. So just kind of really starting to barely get into how this applies to geometry. Here we're told the angles are congruent, that the measure of angle B is equal to twice the measure of angle C. So when you see these lowercase m's, that means the measure of the angle. That's different than talking about the angle itself. Here the angles are the same. Here it's talking about their measures, okay? The measure of angle C equals 45. We're going to prove, this will be our last step, we know where these proofs end up, that the measure of angle A equals 90. So let's go ahead and make a 2-column proof for this. What you can see is I've already gone ahead and put all 3 of the givens in this first statement and said that they were given information. Now I'm going to use this to get to the conclusion. The very last statement will be measure of angle A equals 90. Where I would actually start is, since we're trying to show what the measure of angle A is equal to, I'm going to go up here to where angle A is and state, hey, since these angles are congruent, their measures are equal. That's a really common step to do. You'll get used to seeing that one, saying, all right, if the items are congruent, their measures are equal. So the measure of angle A has to equal the measure of angle B. Notice I'm not using the congruent symbol when I talk about measures, that's saved for when I'm actually talking about the actual angles. So the measure of angle A is equal to the measure of angle B. Now, how do we know that? Well, because they were congruent. If they're the same angle, they're going to have the same measure. That's the definition of congruent angles. So definition of congruent angles. All right, now for step number 3. Here's where I'm going to kind of start making relations with the measure of angle C is 45. And up here it says measure of angle B is equal to 2 times the measure of angle C. So I'm going to actually say that the measure of angle B is equal to 2 times 45. See, I took this and plugged it in for the measure of angle C as such. What I just used was substitution property. Now I could actually say, hey, that's equal to 90. People often call this simplifying. That's fine. You will see the book call that substitution, that you're replacing 2 times 45 with 90. So be mindful that might be called substitution. Now take a look at what I've got. I'm trying to show measure of angle A is equal to 90. I know measure of angle A is equal to measure of angle B. That was helpful because now I know the measure of angle B is equal to 90. So if both the measure of angle A and 90 equal the measure of angle B, then the measure of angle A equals 90. The property I just used there is transitive property. If A equals B and B equals C, then A equals C. That's what transitive property is. Just so you know, some people would argue substitution. That's accepted. I would accept substitution property on that, saying that you took the 90 and replaced measure of angle B with 90 and got your final answer. from using statement 2 and replacing measure of angle B with 90. That's fine. So if you're calling it substitution, good, but it is technically transitive property. That wraps up that proof. And here we are going into our last proof. I'm going to do the same thing, set up as a 2-column, put in my given information here, and try to get to this as my last step. Alright, you can see where I've gone ahead and put the 3 pieces of information that they gave me into this. This is saying segment AB is congruent to segment CD. Segment CD is congruent to segment RS. The measure of AB, see, when you don't have a line segment symbol, you're talking about the measure of AB. You don't use a lowercase m in situations with segments. So the measure of segment AB, the distance between those points, is equal to 12. Our goal is that our last step will be that RS equals 12. So let's go ahead and rock this. Basically, I take these first two, since they're talking about the segments being congruent, I'm going to actually state that their measures are equal. So, excuse me for using the line segment symbol, that AB is actually equal to CD, and that CD is actually equal to RS. And what I just used was definition of congruent segments, that those measures would be equal since the segments were congruent. So definition of segment congruence, or congruent segments would actually probably be a better way to say that, excuse me. Definition of congruent segments. Alright, let's roll with this. What I can say is that since AB is 12, I could say that that is going to be the relationship to CD. That CD is actually equal to 12. See, CD equaled AB, AB equals 12, so CD equals 12. We just use transitive property. Since both 12 and CD equaled the same thing, AB, they equal each other. And that actually helps a lot, because let's take a look here. Since we've now got that CD is equal to 12, hey, look at what we're trying to prove. RS is equal to 12. So RS is equal to CD. Well, CD is equal to 12, so 12 equals RS. Or, simply put, RS equals 12. We just used transitive property again. And that's our last step, because that's what we were trying to prove. Your biggest struggle with proofs is often knowing how to make the connection to your last step. I mean, you know where it starts, and they show you where it's going to end, but knowing how to get there. And the only answer I have for you on how to get better at that is practice. You have to go and do some of these for yourself. If you don't, if you just kind of say whatever about it and you don't practice it all before a quiz or a test, it's going to kick your tail every single time. So this is one of those things where you have to do it. There's no way around it. That wraps up our lesson for today. I appreciate you tuning in.